Welcome to Notes 3.2, Graphing Lines. This video is for Algebra 1. The goal of this video is for us to learn how to graph lines, first through the use of a table, and then through the use of a shortcut, but we will start with the table first. So to begin with, let's look at example 1. It says graph the line 4y plus x equals negative 12. What I would like to do here is to solve this equation for y, and so we begin with our equation 4y plus x equals negative 12. The first move I will make here is to subtract x from both sides because x was being added, and what I will end up with is 4y on the left side of the equal sign. You have two options. You can write this as negative 12 minus x or a negative x minus 12. For reasons that hopefully will become clear later, I'm going to write as negative x minus 12, and this is 4 times y, so if I divide both sides by y, everything on the right hand side of the equation will get divided by y. So what this leaves us with is y equals negative x divided by 4 minus 3, and if you recall, what we have here is a negative 1x minus 4, negative 1x divided by 4. And another way you can write this is y equals negative 1/4 x minus 3 instead of negative 1x divided by 4 minus 3. So what I will do is take my equation and I will write it over here in the table. Y equals negative 1/4 x minus 3. Now, why did I want to solve for y? Well, if I have x values and I was able to plug in these x values, let's say into this equation right here, I would know the x value, I would know the y value, and so then I would have a coordinate. And if we have a bunch of coordinates, we can just plot them on the graph and connect those, and there's our line. Okay, so you can pick any x values that you would like to. I'm going to start with negative 4, and what I will do is use my equation. Y equals negative 1/4 times negative 4, and then we will subtract 3. So negative 1/4 times negative 4 will give me a positive 1, and so what we would have is 1 minus 3. That gives us negative 2. So one of the coordinates that this line will go through is the coordinate negative 4 comma negative 2. Again, you could pick any x values that you want to, plug those into this equation, and you will get a coordinate that you would use to graph this line. The next value I will choose is 0. You can again choose any values you want to, but we'll put in 0 into our equation, or substitute 0 into our equation. So we have negative 1/4 times 0, and then it's minus 3. So 1/4 times 0 is 0. You really have 0 minus 3. So the y value here, when x is 0, is negative 3. And so we have another xy coordinate of 0 comma negative 3. I did have some reason that I chose these numbers here. All these x values did happen to be divisible by 4, so I thought those would be easier for us to use, so that's why I chose these values over here. But again, you can choose any x values you want to. I thought that I would save us some time here with 4, 8, and 12, show the work there. The process is the same as what I did up here. Just wanted to make sure we could save a little time, and we did come up with some more ordered pairs, some x, y coordinates there. And just a reminder, any of your coordinates are always x first, y second, hence the name ordered pair. Okay, so now we have our coordinates over here, the x, y ordered pairs. What I'm going to do is plot these on our Cartesian coordinate system, the x and y axis. Negative 4 comma negative 2. We will begin at 0, 0. The negative 4 means move left 1, 2, 3, 4, and the negative 2 means move down 2. So 1, 2. There is the first ordered pair of negative 4 comma negative 2. The next ordered pair, again, start at 0, 0. And the first value, the 0, that means to move left or right 0. The negative 3 means move down 1, 2, 3. And so there is the second ordered pair of 0, negative 3. Go back to the origin. Now we're going to be looking at 4, negative 4. So let's plot that. We start with the 4. That means it's positive. It moves right 4. 1, 2, 3, 4. Negative 4, it means move down 1, 2, 3, 4. And hopefully we can see that these ordered pairs are starting to form a line. 8, -5, that is our next ordered pair. Start at the origin. We'll move 1, 2, 3, 4, 5, 6, 7. That will actually be off of the graph. If you wanted to, you could continue that. But what I would do is we're going to put that ordered pair right there. 3 ordered pairs, though, is enough to make a line. And one last time, how did I get these ordered pairs? Well, draw your attention over at the table here. Let's say the 4, -4. The x value was positive, which means move right 4, and the y value is negative. That would mean move down 4. And it would work that way for any of the ordered pairs. X values left and right, y values up and down. So hopefully you have a straight edge or a ruler that you can use on your notes now to connect these ordered pairs. So let's draw a straight line through them. And please don't stop at each of the endpoints or each of the ordered pairs. Please extend it through the ordered pairs and then put arrowheads on each side. That way we know that the lines extend in both directions. The last thing we need to do is to label our line. And what I'm going to label it as is the isolated equation, y equals -1/4 x minus 3. If you would like to label it with the original equation, the 4y plus x equals -12, you can do that. It is completely your choice. What I'm going to do now is ask you to skip over the section that says look at the equations of the lines that are shown to you, write down some observations. We will go over that in class as a group, so we will move on to slope-intercept form and point-slope form. Let's fill in the side of the box that says slope-intercept form first. The slope-intercept form of any linear equation is going to look like y equals mx plus b, and m, we hopefully know by now, is the slope, and b is going to be the y-intercept, where the line crosses the y-axis, and the x and the y values, those are going to be left as variables, and we would use those if we were trying to make a table of values like we did in the beginning of this note. What we'll do with point slope form right now is we're going to skip over this section of the box, and we're going to come back to this at a later time, so we'll leave that blank for now. Okay, so let's scroll down here and to the next example, and before we do anything, I want to change this equation. Otherwise, we're going to deal with fractions. I don't want to work with fractions with you on these equations just yet. And so let's rewrite this equation as 3y equals 12x minus 21. So when we're dealing with any linear equation so far, we're going to use y equals mx plus b. So I want you to write that out up top. And as you can see, it's y equals. And so I think that our goal down here should be the same thing. Let's try to make this y equals. What we would need to do to accomplish that is to undo the multiplication by 3 using division by 3. Either the whole side or each individual piece will be divided by 3. And as we know, the 3's will divide out, leaving us with 1y or just y. The 12 divided by 3 will give us 4, and the x is along for the ride. And we'll be subtracting 21 divided by 3, which is 7. And again, we had a 20 up above. That would not have come out nicely. I want to try to avoid that at this point. Well, as with our first example, our goal here is to graph this line. I really don't want to go through and make a table again. I think that's too time-consuming. So we're going to talk about a little bit of a shortcut here. I think we know what m and b are. We have our slope, which I think in this case is 4. So I'm going to write down m equals 4. We've identified our slope. I think we know what b is. In this case, it's 7. It's actually -7 because there's a subtraction sign in front of that. So I'm going to write down b equals -7. We have now identified the point at which the line crosses the y-axis. So we do have m and we do have b. That will be useful in graphing this line without a table. So what the slope means here is that we will move up 4 and right 1. We do have a starting point. What I want you to do is to notate that right now. Here is your starting point, and that is -7. And so begin at -7 on the y-axis. Since we know that we move up 4, right 1, we're going to go up 1, 2, 3, 4, and then we're going to count over 1. There's our ordered pair, and we'll continue to move in that fashion. And continue in the pattern, up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. And now if you could take a straight edge or a ruler and connect those ordered pairs. Extend the line through the first and last ordered pair. We could use arrowheads on each end, and let's label the equation as y equals 4x minus 7. And let's continue with that pattern until we move off the page. 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. At that point, I think you see we won't have any more room to graph our points. Now take a straight edge or a ruler and connect your ordered pairs. And if you would please make sure you put arrowheads on each end of the line, and then make sure you go through and label your equation. I'm going to label your line. I'm going to use the equation y equals 4x minus 7. Okay, let's scroll down to the next example. And before we do this one, I would also like you to change this question so that it is negative 2x minus 8y equals negative 24. So I want to show you two ways to solve for y in this question. The first way is going to be moving the 2x first. So if I copy down my equation, again solving for y, I have a negative 2x. I would like to isolate y, so I need to get rid of this 2x. It's negative, so I will add 2x to both sides. Be careful on that right hand side of the equation. I am going to write the 2x first, and so I'm going to have negative 8y equals 2x minus 24, so that it is eventually going to be y equals mx plus b, and it's negative 8 times y, so let's divide by negative 8, either the whole side or in pieces. I think that I want to go in pieces. I think it'll keep the slope and y-intercept separate for me, and so let's divide out the negative 8s. I'm left with y equals 2x over negative 8 minus 24 over negative 8. Okay, we got a little simplification that we need to do here. Actually, if it's subtract 24 divided by negative 8, when I subtract a negative, I should actually add, and the 2 and the 8, they will reduce, and that will actually turn into 1/4, and it should be negative 1/4 because I was dividing by negative 8. So what we have here is negative 1/4 x plus 24 over 8, and we know that as 3. Okay, now the second option you could have had here was we could have decided to move the negative 8y first, and so negative 2x minus 8y equals negative 24. Since the negative 8y, it is negative, it's being subtracted, I'm going to add 8y to both sides. That leaves me with negative 2x. The 8 and negative 8y, they do cancel out. And what we're going to have here is 8y first minus 24. And then 24, it is negative. I'm going to add it to both sides, trying to get y isolated. So I am left with negative 2x plus 24. And that is still equal to 8y because the negative and positive 24, they did leave us with 0. And as before, we divided by 8. This time, however, we're dividing everything by positive 8 because it was on the other side of the equal sign. The 8s, they will divide out. Y equals 24 divided by 8 is 3, plus, and 2 over 8 is 1 over 4, x, and negative sign there. Reminder, the x can either go in the numerator or multiplied by the fraction on the side. So as before, let's go with m and b. Let's try to actually identify those. Looks like in the either equation, m is a negative 1/4. So we have negative 1 over 4. Remember, x is not part of the slope. It's just the coefficient. The slope is the coefficient. And b is going to be plus 3. And so there is our starting value. We will be starting at 3. That's a positive 3 on the y-axis, and so there's the starting point. We're starting at 3. And in this case, we're going to be going rise over run. I'm going to move down 1 and write 4 from my starting point because it's a negative rise over run. So I'm going to move down 1 and write 1, 2, 3, 4. There is my next ordered pair. And the same thing could be said if I were to go in reverse. I could have actually gone left 1, 2, 3, 4, and up 1. And there would have been another ordered pair. And now with a ruler, I would like you to extend a line through all of the ordered pairs. Please don't forget arrowheads on each end of your line, and we need to label that line with the equation, either the original or the new. I'm going to use the new of negative 1/4 x plus 3. And just one final thing, back to the slope. The negative sign can only go with one of these numbers, the 1 or the 4. And so if I were thinking of it in terms of moving down 1 and right 4, that means I thought that the 1 would be negative, because we would start from the y-intercept and move down 1 and right 4. If I would have thought of this in terms of the negative sign going with the 4, then I would have moved up 1 and left 4 from the y-intercept. So again, up 1 and left 4. And that's where I would come up with my other ordered pair. So again, you're only allowed to put the negative sign with either the top or the bottom, numerator or denominator. Okay, let's scroll down to our last example. It says determine the equations of the lines shown in the following graphs. What I need to actually write the equation is simply the m and b, or slope and y-intercept. And so I would like to, for line A, identify slope and y-intercept. Y-intercept, I think, is pretty easy to do for line A. It's the point at which the line crosses the y-axis, and that point is, in this case, 2. And let's think in terms of rise and run now. If we look for m, you can think of going from exact point to exact point, like we talked in class. Let's go from this point here to that point there. That would be a rise of 1, 2, 3, and a run of 1. So again, rise over run, 3 over 1. You could have also thought of this in terms of going from the top point to the bottom point. So you would have a rise of down 1, 2, 3, negative 3, and left 1, or negative 1. That would have given you negative 3 over negative 1. Same thing, still going to be 3 in either case. And since we are writing our linear equations in the form of y equals mx plus b, we have what we need. We have m and we have b. And now that we know m and b, let's just substitute those in. Y equals 3x plus 2. And there's our equation. Y equals 3x plus 2. And for equation B, or line B, let's pick two exact ordered pairs the line goes through. I've marked those in blue. The y-intercept is right there. So in order to make the equation here, we need to identify slope and y-intercept. Slope here is, y-intercept here is 5. Slope, I would need the rise and the run. So I'm going to go from the leftmost point to the rightmost point. That would be moving down 1, 2. So there's a rise of negative 2 and a run of 1, 2, 3, or a run of 3. Now if I wanted to think of it in reverse, I could have done my run of 1, 2, 3. So I could say run of 3 and a rise of 1, 2. Which is going to give me, again, negative 2/3. So let's think of this in terms, again, of y equals mx plus b. And let's fill in negative 2/3 for m and 5 for b. So we have the equation y equals negative 2/3 x plus 5. So that concludes Notes 3.2. If you have any questions that you are not sure of that I've taught in this video, please circle those questions and either try to watch the video again or make sure you hold on to those questions for next class, and we will go over those questions first thing before we get to our problem set. There is no question with this video, and I will see you next class.